Okay, here's 6.5.1, and we're going to begin to look at specific ratios of legs and hypotenuse. And what I've done here is draw a little bit of I've drawn a specific triangle, and let's just examine it a little bit quickly. So I've labeled this as a 27-degree, and it's a right triangle, so angle B is 90 degrees. From experience, we know that we now have that this triangle with 90, right, and 27 is a specific type of triangle, and that basically any two triangles with these two pieces of information will be similar to each other. In this section, we're going to talk about how the legs and the hypotenuse relate to each other. And we do that with three ratios. Now, if you think about what's going on here, look what happens when I move this one. If you think about the legs for a moment, and we look at AB and BF, the relationship between AB and BF remains constant even though the lengths change. And hopefully you can see that. Now concentrate on the fact that AB, leg AB, and hypotenuse AF, right, those two relationships remain constant. And finally, if we look at leg BF and hypotenuse AF, that that relationship will remain constant. And so in geometry, we have these three different ratios. The first one is the sine ratio, which you'll see here at the bottom. Let me get my pen out here. And the sine ratio says, take a look at the sine of an acute angle, right? We're going to think about 27 in this example, as being the ratio of the opposite leg to 27 over the hypotenuse. So AB in this case as it relates to the hypotenuse. Now, if we change color up a little bit, there's a second ratio, the cosine ratio of 27, right? And that's defined as the adjacent leg over the hypotenuse. In this case, the way the BF relates to AF. And finally, there's a tangent ratio in green. Tangent ratio of 27 is defined as the opposite leg over the adjacent leg. And back in the day, scientists and mathematicians looked at and measured these relationships. And it turns out, of course, because there is only one, not that there's one triangle with a 90 and a 27, but all of them look similar, we can talk about measuring their legs and the hypotenuse and then relating them, because the relationships will remain constant. And so in our next, in this section, we're going to look at things, and you'll be using your calculator to establish what is going on with the legs and hypotenuse, and specifically with like 27. I purposefully did not talk about this angle up here, but this angle up here is a certain size, right? And it also has a collection of ratios. In that case, FB becomes the opposite leg. AB becomes the adjacent leg, and hypotenuse is always the same. Okay, and we will use the calculator to figure some of these things out, but we'll talk about this in practice in the next screencast. But these are the three definitions of the sine ratio, the cosine ratio, and the tangent ratio. Often, sine is related as opposite over hypotenuse. Cosine is adjacent leg over hypotenuse, and the tangent ratio is opposite leg over adjacent leg. SOH CAH TOA. And that's the way to remember it.